Why didn't this all record? 30 minutes of work all down the drain. That's the third time today. Why does it all hate me? Okay, we are here for the first time today talking about an introduction into magnetism, okay? When we talk about magnetism, we're going to be talking about the forces due to magnetic fields. And we can think about these magnetic fields in the same way we can think about electric fields and gravitational fields. They're fields that point in space, and when certain intrinsic properties exist in certain ways within them, those fields can act on certain objects with a force. Now, one of the first ways that we can get a force onto some particle is if it is a moving electric charge. Moving electric charges, if they're in a magnetic field, well, let's state this. Moving electric charges create a magnetic field. And since they create a magnetic field, if they're already within one, they're going to feel a force as those magnetic fields interact. Secondly, if we have a force acting on an electric charge which is moving through a magnetic field, as I just kind of stated, then a force is going to be exerted on it, okay? So those are our main ideas here. It's moving charges give us B fields, and when these B fields interact with each other, we get forces out of that, okay? Because of this, we don't just have electricity, and we don't just have magnetism. This is commonly referred to as electromagnetism, okay? There are two forces that we've bundled into one. We've seen how they've interacted in the world of physics, and we found that they are the same force, okay? But right now we're just focusing on the magnetism side of things. Now, how does this magnetism even exist? Well, I guess that's kind of a weird question, but how do any of us exist? But we know we get magnetic fields due to magnetic spin moments on electrons. Electrons, if you remember back from chemistry, there are certain quantum numbers associated with them. We've got things like principal quantum number n, and then we've got like L, which is I think some angular thing. We've got the angular spin, and then there's actually a fourth one, which is the magnetic spin moment of the electron. And I think these are either plus 1/2 or minus 1/2, if I recall correctly. These spin moments here basically designate if the electron's pointing up or down, because these electrons are going to be generating our B fields here. Now, as we know, for magnetism just growing up through the years, magnets have a north and a south side of things. Mathematically, you shouldn't be able to get magnetic monopole where it's just north or just south. This is opposite from electrostatics, when it was like this is just a positive charge, this is just a negative charge. Magnets have to have both a north and a south. Now, what we're going to talk about in this class right now are traditionally called permanent magnets, okay? They're ferromagnetic materials that hold their magnetism, okay? That magnetism stays. And common elements that do this are cobalt, iron, and nickel, okay? Now, whenever we have a ferromagnetic object, what's really happening here is we have these magnetic spin domains. And these electrons in these domains, they're kind of pointing in random directions, as you see here. Some are up, some are down, some are right, some are left. They're just all random, and all that randomness just kind of cancels everything out. But if you take a ferromagnetic element and you bring it up to what's known as the Curie temperature, named after Marie Curie, if you bring it up to a Curie temperature, what will happen is these electrons will have so much energy associated with them that they will be free to rotate. Okay, right now they're kind of locked into a position, they're locked into these domain states. But if you bring them up to a high enough temperature, normally around like 1000 or 1400 Kelvin, you can allow them to move freely. If you then put them in a magnetic field, or what we'll call a B field, then these electrons in here will align themselves to this B field. When they align themselves, they'll all point in the same direction, as we see down here, and that will generate a net B field for the magnet. And that's how we create permanent magnets that you put on your fridge or your car or anything like that. We heat up these materials, we put them in an established B field, very strong, rotate them all, and then let them slowly cool off, and then it'll lock those domain states into position, okay? Now, when we do this, this side is going to be our north side here. This is going to be our south. We'll talk about how that will happen in our next video when we talk about drawing magnetic fields. But if we take this magnet and we chop it in half, we're not going to get a north and a south side. We're actually just going to get two smaller, weaker magnets with a north and a south and a north and a south. Okay, so every time you chop a magnet in half, you're just going to get more magnets. They're both going to have north and south sides to them. Now, a kind of weird thing that can exist with this is, while we're talking about ferromagnetism here, there are two other types of magnetism. There's diamagnetism, and then there's paramagnetism. And all objects possess these two other properties, dia and paramagnetism. We're not really going to talk about them. It gets kind of weird. But essentially, diamagnetism is the repulsion in a magnetic field, and paramagnetism is the attraction in a magnetic field. But we can kind of do weird things with them. So this is a video, I think a group back in 2008. They were able to levitate a frog due to diamagnetism. So there's our little frog guy floating there. If you take a strong permanent magnet and some bismuth plates, you can get that magnet to like float forever without losing energy. It's kind of some weird stuff going on there, okay? But you need a huge magnetic field, a huge B field in order to do that, just to levitate something like a frog. So it's kind of a lot of energy, a lot of work to get something like that. It's going to be kind of hard to levitate a frog just in your basement, okay? So that's going to be it for this video. In our next video, what we're going to talk about is we're going to talk about drawing magnetic fields and how Earth's magnetic field is a little different than you might be thinking of, okay? So right now, this video is finished. Hopefully the audio has recorded this time. And to everybody out there, adios. Y'all take it easy.